Good morning, ladies and gentlemen. Thank you all for participating in my presentation. My name is Frank Cheng, with my co-author Annie Zhou. We are from National Kaohsiung University of Science and Technology, Taiwan. And today's topic to be addressed is temporal graph warehousing for big data analytics. In this talk, I would like to propose an emerging research roadmap regarding the cross product of these two sets, which inspires four kinds of online analytical processing temporal models on data warehousing and graph warehousing, to make a more subtle and precise big data analytics in cloud event tracing applications. For example, digital contact tracing for COVID-19 related applications, or digital footprints summarizations involved between connected data, connected people, and connected computers in contemporary AIoT applications. Traditionally, we know a data warehouse is usually built by non-temporal relations. By non-temporal relations, it means that the status changing of dimension attributes may not be tracked appropriately. And generally speaking, there are three phases, including data integration, multi-dimensional data analysis, and business intelligence visualization and reporting. When it fails to keep track of status changing in the data source, the derived business intelligence may not be precisely reflecting the real situations. To keep track of all the status changing of dimensions, the source relations can be regarded as three-dimensional relations, using time as the third dimension. This can be implemented by creating a function for each dimension, using datetime as the primary parameter, such that passing different datetime makes the function returns the correct status at the time spot. Such implementation can also be executed in the star schema or snowflake structure by projecting all the time spots for indexing each transaction to the correct version of related dimensions. For example, the first transaction occurs at T1. Then all the T1 version of dimension D1, D2, and D3 should be joined together for further integration analysis. This solution substantially resolves the traditional slowly changing dimension problem, such that the transaction occurs in a specific time spot, namely Ti, will be linked to the right slice, that is, the correct dimension version indexed by Ti. Now we can introduce the concept of temporal dimension with multi-version hierarchy. For example, the two hierarchies shown on top of the slide represent different status at different time spots. They can be merged into an integrated multi-version hierarchy as shown on the bottom. That makes the temporal data warehouse concept should be visualized in a more subtle way, which also inspires more user interface and user experience research direction here. Recently, there are versatile social networking services unfolded in the public cloud environment. As users are drawn in the vast amount of data generated in these social networking activities, graph database model has been proposed for representing the interconnectivity between humans and shared documents or contents. Therefore, the process of obtaining social business intelligence, together with their social network integration and temporal network visualizations, may require more studies to be conducted. Graph database model may also need summarizations, as we do in data warehousing. For example, this complex graph structure may be summarized based on different dimensions or concepts. On the left-hand side, the upper graph can be summarized into a small graph by the gender of all nodes. On the right-hand side, the graph reduction is based on the summarization of the diploma or degree of involved person. Finally, we summarize our research roadmap in this picture. Generally speaking, there are three ways to pursue, starting from traditional data warehousing to temporal or graph warehousing, or more aggressively, their combinations. To conclude our presentation, we would like to raise some questions here for the gentle audience. The first one is what topic or directions should be addressed or studied for the non-traditional dimensional modeling. The second one is what's the impact of the model in each quadrant to the design of a new query language or user interface. And finally, what should be adjusted in the traditional ETL architecture for non-traditional warehousing. Thank you. Thank you for your attention, and welcome to Taiwan.